today our topic's going to be our Productivity 3000, and this we've done. Let me back up. We've done a couple of these already. So we've done like what is a Productivity 3000, what is a pack versus a PLC.
Done an overview.
Yeah, we did an overview. We did a little bit of programming in the beginning. So this one's going to be advanced programming. Tom set up some really good demos we've got here, and he's going to spend most of the time on the software showing you how to do some of this stuff. And then we actually have some more advanced programming that we'll be doing in future seminars. But if you haven't watched the previous 2 or 3 or 4 that we've done, please go back and watch those.
Yep, you can see them on the pre-recorded on the web page for Automation Talk.
Right. Well, like I said, today is going to be our Productivity 3000 Advanced. I'm Shane. I'm the host. Tom Alosky has spent a great deal of time putting together these demos in the program.
And here to my right, your left, is actually one of the P3 CPUs,
right,
with a full rack, and connected to that is a local expansion rack. And then we've actually, over there near Shane, that's what you're seeing on the screen right now, I've actually broke out there's 7 communication ports on the CPU, so we've actually broken those 2 of the Ethernet ports out, one for communications down to one of our Stride switches, and then the remote I/O goes to another Stride. What you're seeing on the video screen right now is actually an expansion rack with a local expansion connected to it via USB, and the 2 are actually interconnected by one long Ethernet cable. And also from the hubs over here by me, we're going all the way over there to the end to a CMOS. So the setup here is basically we're trying to use local expansion and then also slave expansion. We're also going to communicate with a GS drive and a motor, and we're also going to demonstrate some analog stuff, PIDs. And let me say this is part 1 of advanced programming. We're going to come up with a part 2 because in this 40 minutes there's really no way we would be able to cover all the major programming features within the P3 programming software. Let's talk a little bit about the hardware real quick. There's one CPU. It's a P3-550. We have the option of 4 different I/O racks, so we can do 3, 5, 8, and 11 slots. We also have the 7 built-in communication ports, also local and remote I/O capability, and one of the nice features within the P3000 is the built-in 50 megabyte memory, which allows the end user to not only put their project in there, but also you're able to put all your documentation, your run comments and nicknames. Next slide, please. Let's talk a little bit about the hardware. We talked some about it with the 3, 5, 8, and 11 slots. We have an option of an AC or DC power supplies. There's no budget or power budget restrictions. You don't have to worry about, like on some of the other products, actually calculating how much current draws on your power supply. The I/O is hot swappable, and also you might see on our demo here, you probably can't see it there, but we also offer the zip-link wiring solutions that we can connect up with both in direct terminals, fuse outputs, and relay outputs to the units. Next slide, real quick, we'll just talk about there's 35 different I/O modules, all in AC, DC, input, output, and relay output, of course. And if you go to the next slide, we'll also, part of those 35 modules include analog inputs and outputs, both in voltage and current. And we're actually, in our demonstration today, we're using quite a wide range of the analog modules. Actually, I don't think we're using any discrete because all the high-powered instructions kind of involve numeric type values and information.
Yeah, I think discrete is discrete. If you've used PLCs, you've obviously used some discrete. So yeah, everybody wants to get into the more complicated, more powerful modules and instructions. I love those analogs with the displays on them. Those are awesome.
Yeah, maybe we should mention real quick. Yeah, it's a patent pending LCD display on it. And I actually made use when I was setting up some of the demonstration here to actually double check make sure my temperature and distance probes and everything were giving me the correct values, and make sure I had the right channel selected. This next slide, hopefully you see it on your video, is what we're going to cover in the software. So we're going to go right down through these. My engineer told me if I spent 5 minutes on each topic, it would take me 60 minutes, and we're already 10 minutes into the show, so we're going to have to fly through some of them. The first thing I want to do real quick, and we've covered this in other videos, so please, if we go through this too quick, go back to the other videos and see it. But I'm going to bring up the hardware configuration. And if you can switch me back to, I need to get over to the computer up here, the demo computer. And the first thing I'm going to do is actually, you can go to the next slide. They may be able to see it there, but in the slide after that, I think there's even more information. So here's the hardware configuration. Next slide. And basically, we're actually showing the computer. I'm sorry, I'm going to have to do this manually. I apologize. There we go. And just for the heck of it, I'm going to this remote base to my left, to your right, and I'm going to show you the remote slave module. And basically, we're going to demonstrate this. We hooked the printer up to it, so here's how easy it was for me to go in there to that RS-232 port on that slave and actually configure it for ASCII data and set my baud rate and the other numbers.
Now, so you're saying the slave over here, you're communicating with it
through the
CPU,
CPU,
master, and you're also using another COM port on the slave to talk to some other device.
Exactly, which is kind of neat. We also should mention, we mentioned in the past that I can have my CPU over here on the one side and through an Ethernet cable have a remote slave sitting out there with an RS module sitting on, and on the front of that is a USB connection. I can actually walk out there to another location in my factory or plant and plug in my laptop and sit there and program and monitor and make changes to the program.
Cool.
So we got that set up, and I also wanted to show you in the hardware configuration, and I automatically configured these, once we had everything hooked up right from the software. I also took and used an eDrive Ethernet card for the GS drive down here and connected that up to the remote I/O, and it actually brought that up. So what you're seeing there is all the different setup parameters and everything with the ramps and the volts per hertz digital. If you're familiar with any kind of AC drives, basically this is how we can get directly to them, and I can change those parameters and adjust them and set them. And also, with the GS write and GS read commands we're going to demonstrate, I can actually sit here and, through Seymour, actually run and control the drive. Next topic we want to talk about is going to be tag database. So I'm going to show that to you very quickly. If I can bring that up there, hopefully you're seeing this. And I know you're probably not seeing our slides, but if you are, you're also on the video. But here, the whole thing with the P3 is it's tag name database program. So every function, control, and everything else I do, I'm going to use tag names. All the discrete and analog modules already have, an encrypted base slot, bit number type I/O addressing, but I can just as easily, if I got a limit switch that's hooked up to some kind of guard connected up there, I can change that name to that, and then during my program I can do that. So that's just going to give you a general quick overview of the tag database. And also with those tag databases, if you go to the next slide for our reference, we can also export. So once I've set up my programming, I can sit here and do an export tags, and I'm not going to go through the whole thing, but I can create a CSV file with all the tag names. Make sure, because I always forget, if you want to include your IOs, check the little check box to include the IOs here, and create a file name and a folder location, and that's kind of how you do that. And then real quick, once I've created those tags, if I'm going to use them in Seymour, here's part of my Seymour screen development, I can actually come in here and actually import that tag name database. and you're going to see a dialog box pop up here, and you're going to go out and browse for that CSV file and pull it in, and you're actually all set. So, if I take one of my elements within this screen within Seymour, I can actually, see the different tag names I've imported and assigned to the different devices and elements. So back to the P3 software. Let's talk about Task Manager. This is one of the cool features. If you look down here in the lower left corner, we have Task Manager. And you're not seeing the whole thing, but in our demo today, I've created 8 separate examples of advanced programming features within the P3. And to try to keep them uniform and separated and everything, I actually took all 8 and I created a separate task for each one, so they literally have their own programming screen for each one. Mm-hmm. Within the Task Manager, if you look, I have all 8 of these set in here under Run Every Scan. So all 8 of those ladder logic functions that we're running today, they're all running every scan. I can very easily, if for some reason I don't want my GS drive to function anymore, I can take that and grab it and drop it down here under Disable Task. And effectively, that is no longer being scanned, and it won't work. If during troubleshooting, debug, I can take any of the things I'm trying to do, and I can, instead of running them at the full rate, if for some reason I want to run them slower, I can run them every second. I can run them when called, so I can actually do like a subroutine and drop some of my routines or my task within the run when called and call them actually from other parts of the program. And I can also set up parameters and everything, so when the CPU is first, brought up in the run mode, I can, just have certain task or ladder logic run for the first scan only. That was kind of a quick. I'm going to put the GS drive back where it was, but that's was
so basically just click and drag.
Yep, and this is beautiful. I know with direct logic and everything, a lot of times when we're on phone support helping customers, we would give them the little trick of sticking an end statement in between.
Right.
Part of the logic to try to troubleshoot it. And with the Task Manager, if you're structuring and controlling the way you write your ladder logic, you can use this to troubleshoot with. So that kind of covers those points. The very first thing we want to get to, if you can, switch over to Seymour. And what you're going to see is, and if you watch this on the Click Advanced Programming, we did a very similar thing. We called it mixology, but basically we're taking a drum sequencer or a drum timer, and we're actually sequencing events. In this case, we're going to take these 3 tanks filled with different colors and empty them into a mixing tank, mix it, and drop the contents into a tanker truck and then drive away. And we're doing this whole thing basically with the drum timer. So if you switch back to the demo computer, we're going to see the drum instruction. And right here, I'm going to open up the drum instruction. So here's my drum, and it's a little difficult to see on the screen. I know you're not seeing the slides as far as I know, but what's nice with the P3 is I can assign my step numbers, my elapsed time, all the different output functions, and I can put real-world names to them. They're, again, part of my tag database. And once I get this totally developed, as shown here, I can actually take this and dump it out to export it and import it right into my Seymour. And within Seymour, I was able to drop that into the various elements that I wanted to control within the Seymour. So if you switch back to Seymour, hopefully, Shane's going to demonstrate. First of all, we're in manual mode, so nothing's going to happen. So Shane's going to switch us to auto mode, and we're going to start the sequence. And you'll see the tanks filled with liquids, the tanker truck pulled up, and we're slowly emptying into the mixer tank. There goes our green. Here comes our blue color. In a second here, we're going to start the mixer. There's no motion on that, but And then we're filling the tanker truck, and once it's filled, it drives away, and it's saying goodbye to you. Not the broadcast, just the tanker truck. We're not saying goodbye right now.
You want to show the software side of it, and we rerun it again?
Sure, we can do that. We're actually going to see, let me get in the monitor. Okay, we're in monitor mode. I don't know if they're going to be able to see much here, but go ahead and start it. But you should see it's gone through the step number, elapsed times. You know, we're on 1 and 2 and 3 seconds on the different functions within there. But as it steps down, you'll also see, you know, right now output 4 just came on, which is the mixer on. And now we're down to the bottom where the tanker truck is moving. So, you know, you can actually troubleshoot by monitoring the actual ladder logic and everything. Next slide, we're going to go to the drum sequencer. So if you switch back to Seymour, and Shane, go ahead and go to the sequencer. We just did a drum instruction, but there also is an instruction within the P3K, which is called the drum sequencer. And basically, it allows you to sequence events, but within each event, you can have multiple things happening. So switch back to the software. Sorry to have you guys switching back and forth so often, but and I don't know if we can zoom out a little bit on that. But basically, you know, again, I'm setting up my step numbers, my cycle numbers, and the main thing here is I set up 4 steps, but within each step, I can have a whole list of different outputs happen, and I can control, once I go into that step, what the starting value would be and then what the output value would be. So basically, you know, there's a whole bunch of control I can do with the drum sequencer, which again is different than the actual drum. So now if you switch back to Seymour, Shane's going to demonstrate, and if you just enable that by turning that on, and basically, you know, we have 2 flow rates we're controlling here. We're in step 2, so you can see, you know, flow rate 1 went down, flow rate 2 went up. Now we're in step 3, and you know, and now we're in step 4, and this will just keep cycling. So that's the drum sequencer, a little bit different than a drum you might be used to. Go ahead on Seymour, and let's go to the math. And in the math, we did this with the click, but basically just to show the capability of the math instruction, we're trying to show something that's a little more complicated in general. I don't know how many times, you know, you're going to sit and try to figure out your monthly payments on a home loan, but
I like the one we were talking about yesterday. Let's just say we want to buy a helicopter.
Okay, I like that idea.
We'll buy a helicopter.
How much was that helicopter?
You can get a Robinson for what, say $425.
$425,000. Okay, that looks good.
Enter. Interest rate. I don't know what a helicopter interest rate is. Let's just say 9%.
Okay, and how long are you going to take to pay it off in months? 10 years? You might want to go to 120 months for a 10-year loan.
Okay, 120.
Okay.
Enter.
There we go. A little over $5,000 a month. Okay.
You'd have to
we're going to have to put on a lot more shows.
You'd have to give a lot of helicopter rides, but obviously somebody's doing it because you see them up in the air.
Real quick, if you switch back to the demo computer, let me just show you real quick the instruction box. You can leave it there. Basically, it looks like a big calculator, but within the I put my result. All I do is assign some kind of tag name that means something to me, and then I just start putting my formula, and I switch back between formula entry mode and tag entry. So, and I can actually down here, I can, you know, search for different tag names and everything, and insert them right into the formula. And of course, down here I have all my key functions that give me all the normal math type functions with multiply, divide, add, subtract, and even pi and sine and cosine. So that basically covers our math instruction. Next, if we switch back to the over to Shane, we're going to go to analog, and within analog, basically we have a temperature probe that he's holding up in front of the screen, and that's a 4 to 20 milliamp, and we have that tied into a P3-04AD card. And that card, we actually set up a scaling function. I'll show you here in a second. We also have a analog proximity. I'm sorry, it's a proximity with an analog output, and the proximity
All right,
actually.
let me try that one. Hang on a second.
Okay, with the proximity, we can actually show distance.
Well, I'm sort of in the way there. I don't know if they want to back
this
out any, but
proximity will sense from 0 to 10 millimeters, or approximately a little over a third of an inch. So the actual scale on there, it's fairly sensitive. But again, and that's 0 to 5 output, going into a 0 to 5, 0 to 10 analog card.
yeah.
And then finally, we have a damper control. We're controlling with a 4 to 20 milliamp output from an analog card.
If they'll go back down to there, you go. Look at that. All right,
and,
let's say.
Right now it's at 45 degrees, so it's basically half open. Shane just changed it so it's full open, and you probably can't hear or see it, but the actual damper motor there on the side is actually controlling the register vent in there. And if you want to, you can close it all the way down, and we can see effectively we shut off the airflow.
I'm going to do 15%.
Okay, we'll cut down the volume. Excuse me.
And in this heat, I'm sure you'll freeze up the coils on your air conditioner. So,
yeah, it's a little bit. We're going through a little bit of a hot spell here in Atlanta here this past week, a little bit above average temperatures. If you switch back to the demo computer, I just wanted to show real quick a little bit of the analog. There we go. And basically, my input, and I didn't change the tag name. It's basically, what's assigned to that card once the hardware configuration finds it. And through that, I left it as is, but then my output, I created a tag name called temperature 2. And this might look a little bit encryptic, but it's a 32-bit register within the analog card, and it's 0 to 65,535. But because my output's 4 to 20, 4 is actually represented, if you went through the calculations, by 13107. And because I know that temperature probe, 4 to 20 milliamps, is actually 32 to 212 degrees, so that's where you see what I programmed.
So you scale it and everything right there when you set it up.
Yep. One simple little box instruction. I do all my scaling and handling of the data.
Do you remember the days of having to write code, get the manual out, type up calculations? You better have a spreadsheet. You better have your calculator.
Yep. So that's our analog. Now let's jump over to ASCII send, because we're running out of time. And again, this is like part 1 of advanced programming features. With the ASCII send, basically, I don't know if we can get back over to the, there's the Seymour screen, there's the printer. Let's demonstrate it first, but Shane, if you would, I programmed a little message, like the typical C++ basic programmer would do with Hello World.
Mm-hmm.
If you push that button, you're going to see a couple things happen. You'll see the printer advancing. You might even be able to hear it. But also you'll see some of the status bits flicker on and off on that screen. And I also took, and I wanted to show this real quick, but the time is. And basically, now if you could, maybe I could reach over here. Let me advance the printer. And if you can see on the video there, the top is Hello World, and below that the time is, and it's like 14 something or other. And I can't even read it from here. But
there you go. Hold it up.
There we go. Huh? Oh, okay. Zoomed in. So there's our result, just a simple receipt dot matrix printer. But what I wanted to show you as far as the advanced features behind there, if you jump back over to the program screen, I don't know if we can see it down there, but the top one here, I got my arrow on, is actually the where I actually put Hello World, and I was able to put the ASCII text right into the, let me bring that up real quick. There we go. As you can see, whoops, above I assigned the serial port, which is RS-232.1, which is that serial port on the remote slave module. Here's where I put my ASCII text, and then don't have to use them, but I created some tags for the in progress and complete. And I also assigned 2 characters. 0x0d is a carriage return, and I'm pretty sure A or 0A is a line feed.
So what you're showing there is just the instruction, right?
One instruction, I was able to
basically set up the port.
Yep. And you
tell it what to
do. You might see here. Let me slide over, and I set up a push button right here. We weren't going to talk too much about contacts and coils, but
sure.
Yeah, I threw a contact in here, and I called it Seymour ASCII Hello World PB, and I was able to export and import that into Seymour and throw it as a button, and got me all set. The other thing I wanted to show here, because on the time is, that took a bunch of data, and I was able to use, there's a bunch of instructions within the P3 that allow you to handle ASCII strings. So what I was able to do with the pack string is I could put in quotation marks, the time is, it was 15 characters, and then within the P3 we have hours and minutes and seconds and a calendar with the year and month and date. I was able to build or pack a bunch of strings together, and I called that time, and I was able to the send, ASCII send, I was able to say send time, and it actually went in and grabs the current time and everything and sends it out to the printer. Next we're going to jump down to on Seymour. If we go back to Seymour, let's look at a little bit of a receive. There's a lot of things going on this screen on Seymour, as you can see in the video, but what I wanted to demonstrate here is to show all the various flag bits that are available for the ASCII out command. The ASCII out. And basically, we took a barcode scanner with a RS-232 output on it, and we wired it to the RS-232 port on the CPU. Basically what I did here, I can also show how many strings I counted, and there's some enable buttons. I don't know if you can see in the video, but here's my barcode scanner. There we go. And what I've done, if I can find my little sheet here, is I actually created a barcode. I know the camera can't see this, but as you can see, I have 2 barcodes basically. I'll shoot that one. So the first one I just shot is 0380490460, and then the one below it is 041143. But just demonstrating how easy and quick it takes to bring with a barcode scanner or reader that information into the P3. And if we can switch back over to the demo computer.
And once again, that was pretty easy, just to basically plug, set up the port.
Yeah, I have one.
I mean, you didn't have to go in and write code, set up ports in some separate. You just instructions. Here it is.
One instruction. I'll open it there, and again, there's all kinds of status bits and stuff we can set tags up for monitoring or troubleshooting or other uses. And in here, I just said I was going to read that from the CPU 232 port. I was going to use the fixed length of 12 characters. In this case, I didn't need any termination characters, but that's basically all it took for me to bring that barcode scanner in. I think next we have on our list, I think we got about 10 more minutes, and we have 2 more instructions. And again, they're both about as simple as everything we've showed you so far. And the next one I need to go to, if we can switch back to Seymour, and if I can get Shane on Seymour to go to the GS drive. And in the meantime, I'm going to go. There you go. Of course, you saw in the hardware configuration, we were able to take and connect the GS drive up through the eDrive Ethernet card and plug it into the Ethernet remote I/O port on the CPU. And through hardware configuration, we were able to see that drive setting out there. And we showed how we can access that drive and at the same time see all the parameters that are set in it, but we can also control those parameters. But we can also control the run, stop, the frequency, and everything else. So basically, Shane's going to enter a frequency. We have this motor set up for 0 to 60 hertz. What are you putting in there, Shane?
65. No, I'm just kidding.
That's okay.
60. Or, I mean 50. Excuse me. 50.
On an AC drive, you can overspeed the motor.
Yep. 50 and then go to run.
50 hertz, and he's going to start her up. And what you're seeing over there to the left side are all the various status bits that are telling you the communications are taking place between the CPU and the through the eDrive card, and you can actually change the frequency on the fly. But not only can we control the GS drive and the speed, we can also read back parameters on the RPM, the temperature, not temperature, but the current and everything else. I didn't put them in there. Well, also below that, we threw in a jog button, so we can set a jog speed, whatever you want to set there, 0 to 60. And then
half a hertz.
Half a hertz. I think we can. I'm not sure. Let's see if we can do that. Okay, it doesn't like half.
I meant to put 5 in there.
Okay.
There we go.
There you go. 5 hertz. And as you can see, as long as he holds the button, we're jogging the motor. But I mean, now if we switch back to the software screen, I'm going to show you how simple that was to do. Basically, it's one instruction called GS write. There's the various buttons I programmed for the run and the jog. These 2 buttons down here, these are one-shots. They basically allow you to set up the various run parameters and the stop parameters for the drive. And if I open the on, this is how, this is the whole box. I assigned my tag names. I wasn't very fancy. I know I was doing the GS write command, so everything began with GS write, so I could easily find them. And then in progress, complete. These are all the status bits. Really didn't have to do anything with the polling time because I identified the drive when I set it up. I knew that was going to be mode or node 1. Excuse me. And then down here below are all the different parameters I'm allowed to program for the run mode, and then I also have parameters I can set up for the stop mode. So I can set everything up from my volts to the frequency to my minimum speed, my max speed, max RPM, I should say. I can do even PIDs through this control. But again, one instruction. I also have a GS read instruction we don't show here, but I can actually read the various parameters coming back from the motor. If we switch back, we have one more last thing. We've got about 2 minutes left. If we switch back on the Seymour screen to, we need to go to the PID. And with the PID, let me get to that software section here. Basically, in Seymour, there's actually a template for a PID screen where you can actually program in your process variable, your set point, and actually show your output. I also I brought out, just so we could see the proportional, integral, and derivative values that we actually came up with by auto-tuning. I'm going to show you that screen in a second. But just for grins, we needed to come up with some way to, control some variable. So in our case, we got a little bit out there in left field. I'm kind of a fan of Mythbusters, so at this point I should kind of warn you, we're not really professionals, but don't do some of the stuff we do here. We have a lot of backup and stuff, but basically, what I wanted to do is I wanted to monitor temperature.
We make good demos.
We make good demos. I wanted to be able to monitor temperature, so I used one of our ProSense RTD temperature probes with a 4 to 20 milliamp put. And I'm thinking, okay, somehow I'm going to monitor temperature, and I need to control the heat that I put into something. So I thought, well, a terrarium, although this isn't really a terrarium per se, be a good thing because, if we had lizards or snakes or something, they like kind of a warm environment. And what you're seeing now is the temperature went down, and we actually took a GS1 drive, single-phase input, that has 3-phase outputs. This was a little bit unique, but took 3 little 40-watt light bulbs that put out some heat. And we wired them in a Y circuit because they're 120, and although the drive is a 220 output, by connecting them to Y, we're putting about 220 across. basically two 120-volt bulbs wired in series. We set some parameters on the GS1 drive to get it, down there in the lower frequency because these bulbs do put out a lot of heat. And of course, we needed to have Smiley in there with some. We didn't harm any animals or lizards or whatever, so we came up with some baby dinosaurs in our desert scene here. But basically, the GS1 drive allows us to control the output with a 4 to 20 milliamp input. So if you switch me back over to the demo screen, I wanted to quickly show the actual, right here, we actually used the scale in instruction to bring in the input for our process variable, which is the temperature. So again, it's 4 to 20. That's where that 107 to 65,535, and I use 0 to 100. It's kind of arbitrary since our temperature probe can do the 0 to 300. This easily could have been 0 to 100, but I just tried to keep the numbers easy to use. And the same thing, I took the temperature output, and I'm bringing that back in from the drive and basically doing the same thing. And then the actual PID loop, oops.
Does that software have spell check?
I hope so. No, did I misspell it now?
No, I'm just messing with you. I'm just looking at terrarium, and I'm like,
I'm not sure if there's 2 R's in terrarium or not, but anyway. And like our engineer Lauren pointed out, it's not really a terrarium. Terrarium would be what? With live plants and not plants only, not necessarily animals. Even
miniature dinosaurs.
Miniature dinosaurs. But here's our PID. Again, the simple, fill in the blanks with labels and you set the whole thing up, and we can actually set up the P, I, and D. And the great part of all this, and let me explain real quick, this isn't one of the best examples for a PID because here, we can put heat into the application, but we really don't have an easy way other than convection to get the heat out. So, I mean, I'm quite happy it's controlling the set point around within a degree the way it is. But what I can do within, I'm not sure we're going to be able to see this in the video, but I actually was able to bring up the PID tuning loop here. It's built into the Productivity3000, and by putting my PID in a manual mode, I was able to come down here and hit start, and it actually said here and controlled the application or the PID loop, and while it was doing it, it had to go through 3 iterations of above set point, letting it come back down, bringing it back up, and once it established all the timing, the delta, and everything else it took to get there, it actually came up with the values that it did, and ever since then it's been controlling around that set point. So again, I don't want to make light of how simple this was, but it was one instruction I was able to take and come up with a PID. Time's up. That was the wrap up. I hope you come back and watch part 2 because there's quite a bit more features, flexibility, and programming ability within the Productivity3000 software.
Now, these examples, do we have these examples? Because I know customers are going to ask somewhere we can maybe stick them, or maybe we'll send them over to tech and have them put them on their website.
Yeah, I think I know when we did Click after the fact, I actually took and created a binder, and I haven't shown you yet, sorry.
That's okay.
But I actually printed out all the software and stuff, and all the little stuff like the barcode and how we got there and set that up. I kind of documented that because, to be honest with you, tomorrow I'll forget half of this stuff.
Oh, yeah, no, I know.
So by doing that, we can actually take some of the documents and examples of programming. I was thinking, we can run it through tech or possibly
put it on the Learn site.
We could actually put it on the Learn site. We'll sit down.
I just know that after the show, we always have some customers who are asking, I like that example, or I want to play with that example, or I want to see that example. But
I should mention real quick, if you want to play with the example of using a GS drive to produce heat through light bulbs, you get it's not really a good application because a light bulb, when it's cold, has a very low temperature. So basically, I have to kind of tether these light bulbs a little bit to get the filaments warm, so they don't trip the drive out on overcurrent. So just a warning.
It just gives you good practice at playing with all the equipment and finding out the ins and outs.
Kind of a cool effect watching the filaments flicker at the low frequency. So.
All right, so we're going to stop for a second. We're going to do our Q&A, then we'll wrap up. We have a couple questions come in. So if you have any questions for us, go ahead and ask on the slide. There's a little tab that says Ask a Question. Select on that. Ask anything you've got. Like I said, a couple people have already found it. The first one is, the software still free for the P3000?
Yes, very definitely. It's on a limited time for you and I, because we like this product. I hope our management people see fit to keep it free forever, but we can't control that. But please, if you're even thinking about using this, go out and download it and try it. You can do all the setup and everything offline.
Hey, here's one.
Okay.
Download the software for free. Buy yourself a P3000 hardware system, play with it, and send it back.
30-day money back, but hopefully what you'll find is, it's going to do everything you might need for an application.
And more.
And more.
And a lot of people look at the price of it and they're like, wow, that's pretty expensive, or it's more than what I was paying for. No, when I say expensive, I'm saying versus a Direct Logic. If you were to compare the P3000 with other brands, no, you're going to be right on line, maybe cheaper. But if you're looking at compared to a Direct Logic, say 205, 405, yeah, you might be paying a little bit more. But the things that you're showing today, just the ease of programming, the power that you have, and I mean, Tom just barely touched the capabilities of what this thing can do. So, yeah, you're going to save yourself a lot of time there. Yeah. So the software's still free. All right, next question. Here's a good one. And Tom, to be honest with you, it's been so long since I've played with some of the PLCs. The customer's saying the 205 will allow more than one computer to monitor the program. I noticed the 3000 says it's busy via Ethernet. Engineer, you want? Yeah, because the P3000 is actually USB that you program with. Now, right. I know you could program it through the CPU, and you could also go through an expansion and a remote. To be honest with you, I've not tested that. Tom's not tested that.
No,
but
that's one. Keep that name, and please, we'll try to get you a response back from
Mr. Jargo. We'll get an answer, because I can guarantee you that our engineers over in the next building, they have definitely tried that, or they'll have an answer for us really quick. It's just Tom and I haven't tried it.
Yeah, and I would hope, to be honest with you, I would hope there would be a way that I can take, and whether it's through USB and Ethernet or something,
right.
be able to monitor the program from two different computers.
Here's how we can answer it. We're not lucky enough to have multiple PCs in here. All right. No, but we will get an answer on that one. Okay. Do we plan to add more modules, high-speed counters, stuff like that? Oh, yeah. I mean,
definitely.
When we launched the P3, it's one of those things. If you look at the timeline on any of our PLCs, you don't launch everything all at one time. You try to get out what you can and build off of that. Now, they have been working on many more modules ever since the beginning of the P3. There are just some of them that are taking a little bit more time, or they're wanting to add a few more features that customers are asking. Because we'll throw beta stuff out, and customers will come back and say, hey, why don't you go ahead and add this in there? So they'll try to go out and... what is the time of execution of one Boolean instruction? Now, we had that on one of our slides for our original P3. I don't remember offhand.
I think 1,000K will execute in 0.6 milliseconds.
I know that's...
that sound right, engineer?
It's on the specs. We had it on our slide on our original P3. And some people came in a little later than from the beginning. We've had, I don't know what, we did 3 pre-recorded on the P3, and then we did several live ones, right? Just a general overview on P3, and we have a lot of that info. If you haven't watched any of those, I suggest you get a second. Go back and watch the pre-recorded ones. We'll give you a lot of information on that. But don't worry, we can also... This is one of our customers actually in Russia that's asking that question, but we'll be glad to get back with you on that one.
Sure. Yep.
All right, we're going to go ahead, and if you have any more questions, please ask. Don't worry, we'll just email you directly, but we're going to go ahead and close out because we're running out of time. So thank you for those questions. Those are good questions. We like getting stumped. Tom and I are just two people, and we have over 8,000 products, so it's a lot for two guys to know, but we have the resources here in-house at Automation Direct, so we can always find the answers for you.
Yep.
Thanks for coming in, everybody. Hope you have a great day.
Thanks.